Cauchy's residue theorem, a new topic for you guys. Let's start. Cauchy residue theorem. What this says, suppose fz is analytic inside and on a simple closed contour C, except for isolated singularities at z1, z2, z3, zn inside C. Let the residues at z1, z2, z3 so on up to zn be alpha 1, alpha 2, alpha 3 up to alpha n respectively. Then integration over C on fz dz is equal to 2 pi iota into sum of all these residues, right? That is summation I going from 1 to n alpha I, where alpha I are your residues at z1, z2, z3, right? Now, this is very clear that singularity is what? Where the function is not analytic, right? So let's start with the proof. About each singularity zi, construct the circle ci contained in C such that ci intersection cj is equal to phi, right? So suppose we are having the singularities z1, z2, z3 inside the circle C. Keep in mind that these singularities are inside the circle C, right? Suppose I'm having a circle C, and within this I'm having singularities z1, z2, z3, z4, and for z1 I have constructed a circle C1, for z2 I'm having the circle C2, for z3 C3, for zi Ci, such that no two circles intersect with each other. That is, if you take any C1 or C2 or C1 with C3, they should not intersect. So their intersection is phi. You have to take the circles and singularities like this. Now, since the residue of fz at z equal to zi is, yes, if residue for z1 is alpha 1, for z2 alpha 2, then what is the residue for z equal to zi? It is, yes, alpha I. Very good. For all I is equal to, this is very important to write, up to n. Fine. Therefore, 1 over 2 pi iota, this is the formula for residue which we have learned in the last video. So 1 over 2 pi iota integral over Ci fz dz is equal to alpha I. For all I equal to 1, 2 up to n, and mark this as your 1, which simply implies you take 2 pi iota on the other hand. So this is integral over Ci fz dz is equal to 2 pi iota alpha I. For all I is equal to 1, 2 up to n. Just mark this as 1 or star, whatever you like. Now by Cauchy's theorem for multiply connected region, we get integral over C fz dz is equal to sum of the integrals over Ci's. Alright. So this integral, the value for this integral, just apply 1. What you will get, because this is for the circle C1, so this is 2 pi iota alpha 1. Plus, for this we have 2 pi iota alpha 2. So on. For this we have 2 pi iota alpha n. Take 2 pi iota common. This is equal to 2 pi iota common, and this is alpha 1 plus alpha 2 up to alpha n, which is nothing but sum of the residues, right? Alpha I, where I starts from 1 to n. Proved? Hence the result, right? So hence integral over C fz dz is equal to, we have proved this is equal to 2 pi iota sum of the residues, right? where the integration along each interior contour is counterclockwise. You can see the direction for each contour is counterclockwise, right? Hence, this integration fz dz is equal to 2 pi iota summation I going from 1 to n alpha I. This is what Cauchy residue theorem is. The result. You have to learn this result. Now there is very important remark. If fz is a non-constant function analytic at z0 with f of z0 equal to 0, which means what is the point z0? It is a 0 of fz. F of z0 equal to 0 means 0 of fz, right? Then f dash z over fz has a simple pole at z0. Just need to keep in mind. Then these remarks are very important, which are very useful in quickly solving the objective type questions for UGC NET exam. If fz has a 0 at z0 of multiplicity alpha, then residue of f dash z over fz at z equal to z0 is alpha. Means whatever you are having the multiplicity for 0 of fz, right? Whatever be the multiplicity, just write down the residue for f dash z over fz is that equal to that multiplicity, that is alpha. Suppose you are having the function fz equal to z minus 1 cube, and it is asked to find the residue for this function, right? So fz has a 0 at, yes, fz has a 0 at z equal to 1 of multiplicity. What is the power here? 3. Now let's check whether residue comes out to be 3 or not, because we are saying in the remark that whatever be the multiplicity, the answer for the residue is 3. And we are finding the residue of f dash z over fz. Keep in mind. So since f dash z over fz is equal to, just derivate fz, you get 3z minus 1 square over what is fz? Z minus 1 cube, and that is equal to 3 over z minus 1. Now what is the residue for f dash z over fz? How we find the residue? What is the residue for that? The coefficient of 1 over z minus z naught. Yes. Now here, what is the coefficient? 3. So the residue comes out to be 3. I have written this in the remark in the previous video that residue for function fz is equal to any function that is equal to coefficient of 1 over z minus z naught. So here if we find the residue for f dash z over fz, this is the coefficient for 1 over z minus 1, that is 3. Alright, so again I am reading the remark. If fz has a 0 at z0 of multiplicity alpha, then residue of f dash z over fz is alpha. Just check your multiplicity and write the answer as alpha, right? For the residue of f dash z over fz. Now the second remark, this is very important. If fz has a pole at z0 of order beta, then residue of f dash z over fz at z equal to z0 is minus beta. When we are talking about the multiplicity, the answer of residue is same. When we talk about the order, that is beta, then the residue will be negative of that order. Let's look for example. If fz is equal to 1 over z minus 2 the power 5. Remember here now we are looking at the denominator. In the previous example, we are talking about the 0 of fz. See. So we are going through the numerator. Now we are checking about the denominator part. And when we check about the denominator part, that means we are talking about the pole. So then fz has a pole at z equal to, yes, z equal to 2 of order 5. Right? Now check. whether the residue of f dash z over fz comes out to be minus 5 or not, because if the order is beta, then residue will be minus beta. Let's check. Since f dash z over fz is equal to, find the derivative of fz, you will get whatever you will get, then divide by fz, you get minus 5 over z minus 2. After solving, you get this minus 5 over z minus 2. Now check. What is the residue of f dash z over fz at z equal to 2? Yes, what is the residue? The coefficient of 1 over z minus z naught. Now here z naught is 2. So what is the coefficient? It is minus 5. So now you got it. And having the pole of order 5 and getting the residue to be minus 5. Right? So when we talk about the multiplicity, the answer for residue of f dash z over fz is same, that is alpha. When we talk about the pole for order beta, then the residue will be negative of that beta. Right? So there is no need to find the residue. Just learn these two remarks and write down your answer. Just for objective type questions. Right? Alright. Next. There are two notes over here. Cauchy's residue theorem says that if fz is analytic inside and on a simple closed contour C, except for the isolated singularities at z1, z2, z3 up to zn inside C, let the residues at z1, z2, z3, zn be alpha 1, alpha 2 up to alpha n respectively, then integration over C fz dz is equal to 2 pi iota times the sum of the residues, where your n is finite. This you have to keep in mind. N should be finite. Second note, when we are applying Cauchy's residue theorem, keep in mind that there should be no singularity on the contour C. All the singularities are inside your C. Right? This you need to remember. So this is all about the video. We will meet in the next video and we will be doing argument principle. Stay blessed forever. Goodbye.